Here we're looking at how to flash the Powertech MS6106 Wi-Fi smart plug from Jaycar with Tasmota. If you've purchased one recently, you're likely to find that the over-the-air jailbreaking exploit has been patched. Here is a procedure to dismantle the device, force an install of Tasmota, and reassemble with as little damage as possible. The trick to opening the case is to crack it open by squeezing the corners together until the sides pop out. Continue with each corner combination until all four sides have popped out. I've added card here to help the removal process, but it wasn't necessary and you can skip that. Here I'm realizing the spanner that I'm using isn't big enough for the longer sides. I sorted this out by using the grips on the spanner to achieve the same effect. This is my first attempt to work out the kinks. You can see that I've cut out the corner to get a better idea of the dismantling process. The ESP8266 chip we want to program is here, and the GPIOs for the chip are exposed underneath the PCB. The only thing holding the PCB in the unit are these three pins connected to earth, live, and neutral. You'll have to remove the solder to get the pins free of the PCB. Here I'm trying a solder wick and flux to wick the solder away. This did work, but introduced too much heat for too long, causing the casing to melt. The damage wasn't too bad, but I did switch to using a solder sucker instead. That process was much faster. This is attempt number 2 with minimal case damage and cleaner solder removal. These are the internal pins of the prongs that go into the wall socket. We'll put that aside for now. And here are the GPIOs that we'll be connecting to flash the board. We're interested in the 3.3 volt VCC pin, ground, receive, transmit, and GPIO 0. I've also highlighted GPIO 2 and GPIO 15 as they can come in handy for troubleshooting a failed firmware upload. But unless you've done something as stupid as I did, you're likely to not need these. Start by connecting pre-tinned jumper cables. I'm connecting 2 of these to ground, one to supply power and the other one to pull GPIO 0 low. Then connect 3.3 volts to the VCC. Then receive RX. And transmit TX. And finally GPIO 0. I'm connecting the second ground and the GPIO 0 jumper to a breadboard with a push button between them. I'll be using a Wemos D1 Mini ESP3266 device to act as a USB UART adapter. The boards I had available to me from left to right were the WR00M32 board from AliExpress, in the middle an Arduino Nano, and on the right the Wemos D1 Mini ESP8266 board. The WROOM32 on the left produced 5 volts on the receive pin for reasons unknown, so that's not suitable. The Arduino Nano is a 5-volt chip, so that isn't suitable either. The only board that I had that would work was the Wemos D1 Mini, and that has the required 3.3 volt pins on transmit and receive. I recommend checking your board with a multimeter before connecting it. I connect the Wemos D1 Mini to my PC with a USB cable, and it has appeared as COM6. I've connected the ground pin to the reset pin to make it act as a USB UART adapter. This smart plug has never been powered on before, so the default behavior is flashing LED. I'm using Tasmotizer. Select release and leave the default Tasmota bin. Next, put the board into upload mode by holding the button to bring GPIO 0 to low. Remove power from 3.3 volt, reconnect 3.3 volt while the button is still pressed, then release the button after a second or two. Now click Tasmotize. It'll take about a minute to upload the Tasmota binary. Once you're prompted to restart the device, you have a jailbroken smart plug that will broadcast a Tasmota hotspot. Use your mobile phone of choice to connect to the hotspot. Often the device's webpage will open when you connect, but if it doesn't, open a browser and browse to 192.168.4.1. Here you want to enter the details of your own wireless network. Select the SSID and enter the password, and then press save. At this point, I've moved to my PC to continue. My router tells me that this device has an IP address of 172.16.32.18, so I open that with my browser. You want to copy the Jaycar template from the Tasmota wiki linked below. Back on the device, select Other, and paste in the template. I've selected Activate, then Save. You then want to copy the switch mode 1-3 code from the wiki, and on the console page, paste the code and press enter. Then verify the main configuration module page has Jaycar selected. Then press save. You're now all done and can put the device back together again. The tricky part here was reseating the PCB, as the earth prong did not want to go through the PCB. The secret sauce was to add solder to the prong and reflow it while pressing down on the PCB. When the 4 corner pins are inserted firmly, add solder to the remaining prongs. Apply super glue at all the joins and press the shell back together. And now you're all done. Hope you had as much fun as I did.
See you next time.